Yes, my dear students of 10th standard, nowadays we are revising about types of chemical reactions, Unit 10. Unit 10 types of chemical reaction. Already we have discussed up to decomposition reaction. Now we are going to discuss about single displacement reaction. Before that, we have to revise what we have studied in the previous class. That is, a chemical reaction involves breaking of old chemical bonds and formation of new chemical bonds. So chemistry mainly focuses chemical reactions. So chemistry means chemical reactions, and there are so many reactions are taking place in and around us, and digestion of food, the movement of vehicle, and rusting of iron, photosynthesis. All these are chemical reactions. So during the chemical reaction, the reacting molecules, atoms of reacting molecules are rearranged to form a new molecule, and old chemical bonds broken, new chemical bonds are formed. Bond breaking absorb energy, whereas bond formation releases energy. Then normally we use word equation to represent the chemical reaction. Then now we have to learn how to write chemical reaction using formula. So you should know the name of the reactant and name of the product and their formula. You have to substitute the word equation, name of the reactants, name of the products are substituted by the chemical formula. Then we have to balance whether the atoms of the reactants are same number to the atoms of the product. And the types of chemical reaction based on the manner by which atoms of the reactants are rearranged, we are classifying into different categories. Combination reaction. Combination reaction is a simple type of reaction here. Two or more reactant combine to form a single product. That is combination. And combination also there are three types. Element combined to element to give a compound product, like sodium plus chlorine, sodium chloride. Then compound plus element, compound, phosphorus trichloride, and chlorine gives phosphorus pentachloride. Then compound plus compound gives compound. Silicon dioxide plus calcium oxide gives calcium silicate. Then the decomposition reaction we have learned, this is a completely opposite to the combination reaction. A single compound break into simpler products. A single compound split up into simpler substances. That is called decomposition reaction. Then the decomposition reaction, normally the breaking of bond require energy. Energy may be in different form. For example, some reaction requires heat energy, some reaction require electrical energy, some reaction requires energy from the sun. Based on that, thermal decomposition, electrolytic decomposition, photo decomposition, three types are given. In thermal decomposition, the molecules are dissociated by absorbing heat energy. So this is also called thermolysis. For example, when mercury 2 oxide is heated, mercury and oxygens are obtained. Similarly, calcium carbonate on heating, calcium oxide and carbon dioxide are formed. And next to see electrolytic decomposition. Electrical energy is used for the decomposition of molecule like sodium chloride into sodium and chlorine. Then in the photo decomposition reaction, When the compound is exposed in presence of light, the molecule break down into simpler component. Example, silver bromide. When exposing in presence of sunlight, silver and bromine are obtained. Now we are going to learn about single displacement reaction. Single displacement reaction. So it is a reaction between an element and a compound. Reaction between an element and a compound. So when these two are react, one element of the compound reactant is replaced by the element reactant to form a new compound and an element. The general schematic representation of a single displacement reaction is given as. So you have to understand clearly, two reactants are taking part. One is an element, another one is a compound. See, A is an element, BC is a compound. So reaction between an element and compound. And in this, the element reactant, that is A, displace or replace an element from compound BC. An element reactant A displace or replace an element from compound BC. So here an element A displace B from compound BC. An element A displace B from compound BC. So B is removed separately in the product and A going to accompany with C. So a new compound is formed, that is AC and B, because an element A displace B from compound BC. So A displaces element B from the compound BC, and hence a single displacement, because one element only displaces another element, so it is a single displacement reaction. For example, zinc is an element, HCl is a compound. So zinc when react with hydrochloric acid, what happens? See, zinc react with hydrochloric acid, zinc displace hydrogen. So the hydrogen gas H2, the product side, that is displaced by zinc metal. So zinc displace hydrogen gas from hydrochloric acid. So hydrogen is replaced. In the place of hydrogen, zinc accompanied with the chlorine to form a metallic salt in the form of aqueous solution, zinc chloride. So zinc react with hydrochloric acid, hydrogen is replaced by zinc and hydrogen gas is liberated, zinc chloride is formed. Similarly, one more example, iron, Fe, iron, solid state of iron, will react with the aqueous solution of copper sulfate compound. So here iron is an element, copper sulfate is a compound. So iron when react with the copper sulfate, iron is more reactive than copper. So iron displace or replace copper from copper sulfate. So iron displace copper from copper sulfate. So copper is separated. In the place of copper, iron combined with the sulfate to give iron sulfate, ferrous sulfate, aqueous solution of ferrous sulfate. So here, if an iron nail is placed in the aqueous solution of copper to sulfate, as shown in the picture, the iron displaces copper from an aqueous solution and so formed copper deposit over the iron nail. So before the reaction, see, when you are going to keep iron nail in the copper sulfate solution, copper sulfate is bluish in color, blue color salt. When dissolved in water, blue color solution will be formed. So when you keep iron nail in the copper sulfate blue color solution, after some time, After a few hours, what happens? See that ion displays copper from copper sulfate. So what happens? See that copper sulfate turned to ferrous sulfate because of the displacement of copper. So the bluish color turned to green color because ferrous sulfate is greenish in color because copper is replaced by iron. Why copper is replaced? Because iron is more reactive than copper. So normally more reactive elements displace less reactive element from its compound. So iron is more reactive than copper. So iron replace copper from copper sulfate. That's why you see the blue color turned to greenish because of the displacement of copper from copper sulfate. Then it is easy to propose so many reactions of this kind with the different combinations of reactant, different combination of reactants. Will they all occur in practice? No. This is most easily demonstrated with halogen. Let us consider the following two reactions. So all the reactions are not taking place, but we are writing simply in the form of equation. Normally, the highly reactive elements displace less reactive element from its compound. So here one example is given. See, sodium chloride 2NaCl. Sodium chloride aqueous solution, salt dissolved in water aqueous solution. When react with the fluorine gas, it's going to give sodium fluoride aqueous solution plus chlorine gas. So here see sodium chloride plus fluorine. So fluorine in the first reaction, fluorine displays chlorine from sodium chloride. Fluorine F2. Fluorine means F2 that displays chlorine in the sodium chloride. Cl is chlorine. So fluorine displays chlorine from sodium chloride to give sodium fluoride and chlorine. Fluorine can easily displace chlorine because fluorine is highly reactive than chlorine. Fluorine is highly reactive than chlorine. So this reaction easily takes place. You see the second reaction, sodium fluoride when react with the chlorine, sodium chloride and fluorine is obtained. It is given in the form of equation, but the second reaction will not occur. Second reaction will not occur because fluorine is more reactive than chlorine. Fluorine is more reactive than chlorine. So chlorine cannot easily displace fluorine from sodium fluoride. The Cl2 is less reactive than fluorine F. So Cl2 cannot replace fluorine from sodium fluoride. So that reaction will not occur. So in the displacement reaction, the activity of the elements and their relative positions in the periodic table are the key factors. So the activity, the reactivity of the element and the position of the periodic table, these are the two important factors which determine the feasibility of the reaction, whether the reaction taking place or not. Going to be considered their relative position and their activity of the element. And normally more active elements readily displace less active element from their aqueous solution. More active element. So how to understand here? See, here is simple table is given. You can learn from this table. See, in the activity series, potassium is highly reactive than sodium. Then sodium is highly reactive than lithium. So it is in the order of decreasing. Potassium is highly reactive, then sodium, then lithium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, non-metal, copper, silver, gold and platinum. So platinum is very less reactive. The platinum, gold will not easily react. That's why they are obtained in the form of native state. which is highly reactive in this order. Potassium is highly reactive. The next sodium, the next lithium, like that it would come. So the uh, iron is less reactive than zinc, and iron is less reactive than copper. That's why iron easily displays copper from copper sulfate solution. So highly reactive elements only replace less reactive element from its compound solution. To remember this activity order, this series, a simple format is given. To remember a simple story like a method is given. Let us see. Please send lions, cats, monkeys, and zebras into lovely hot countries. Signed, General Penguin. This is like a simple a format, easy to understand. Please send lions, cats, monkeys, and zebras into lovely hot countries. Signed, General Penguin. See, the first letter of these elements are used here. First letter, potassium first letter, in the first letter of please, P. Sodium first letter, that is S. Name, you have to take name, sodium, S. Send, S. Lithium, L first letter in the lion. So such a way they used to give a simple format to understand the reactivity order. Then next to see, which of the metal displays hydrogen gas from hydrochloric acid? Silver or zinc? From this reactivity order you can understand. See, which of the metal displays hydrogen gas from hydrochloric acid? Silver or zinc? See here that zinc only can displace hydrogen from hydrochloric acid, because you can see zinc is more reactive than hydrogen. Silver is below the hydrogen. That means silver is less reactive than hydrogen. So less reactive silver cannot displace hydrogen from hydrochloric acid. So zinc can displace hydrogen from hydrochloric acid. You can write equation. I give word equation. You can write and practice in your rough notebook. Zinc plus hydrochloric acid gives zinc chloride plus hydrogen. I repeat, zinc plus hydrochloric acid gives zinc chloride and hydrogen. So you write and practice and check whether the equation is balanced or not. Next, see, in the activity it is given. See, take about 50 ml of toilet cleaning acid. It is going to be normally acetic acid, and put a iron nail and observe what happens. See, do you recognize any change? So what happens is that iron gas is going to be displaced. Iron gas is going to be displaced and metallic salt will be formed. That is, small bubbles will be arise when you are going to see. Then acetic acid plus iron, you write the displacement of hydrogen, and the remaining will form a metallic salt. Then next, see double displacement reaction. So in the double displacement reaction, above what we have learned is single displacement. Single displacement means one element react with the compound. So one element displace another element from the compound. But here what takes place? See, when two compounds are both the reactants are compound and their ions are going to be rearranged. Their ions are interchanged. Then the reaction is called double displacement reaction. So you have to simply understand. So two reactant, both the reactants are in the form of compound and their ions are interchanged to form a new product. So these type of reactions are called double displacement reaction. So the ion of one compound is replaced by the ion of the another compound. And ions of identical charges only interchange. That means a cation can be replaced by another cation. Anion can be replaced by another anion. Cation means what? Cation means positively charged ion. So positively charged ion replace another positive charge ion from the next compound. So this type of reaction is also called metathesis reaction. The schematic representation of double displacement reaction is, here see, it is given two compound AB plus CD. AB is one compound, CD is another compound. And in this compound AB, two elements are there, and compound CD, two elements are there. Here see, the element B is replaced by D. The element B is replaced by D, or element D is replaced by B. Both are same. So that's why I already say that cation replace cation. Cation replace cation. So here, when instead of B, if you put D, what happens? The product AD is formed. Instead of D, if a B going to occupy the place, CB is going to form. New products are formed. For a double displacement reaction to take place, one of the product must be a precipitate or water. By this way, there are major classes of double displacement reaction. So, two types are given: precipitation reaction. That is, when aqueous solution of two compounds are mixed, if they react to form an insoluble compound and a soluble compound, then it is called precipitation reaction. The precipitation reaction is nothing but any reaction that produce a precipitate. Precipitate is an insoluble substance. That substance will all be soluble in water, which is going to be a curdy like a thick precipitate will be formed, that will be deposited at the bottom of the test tube. So the reaction produce precipitate, it's called a precipitation reaction. So in this precipitation reaction, precipitate and soluble compound, two compounds will be formed. Because the insoluble compound formed as one of the product, it is a precipitate, and the reaction is called precipitation reaction. Then see the example here. See, and before that it is given the difference between a combination and decomposition. Combination is nothing but one or more reactant combined to form single product. Decomposition, single reactant decomposed to give one or more product. In the combination, energy is released, but decomposition reaction require energy absorption take place. So in the combination, elements or compounds may be reactant. Element, compound. Three types already learned. Then here in the decomposition, only single compound going to decompose. This split into different products. Then when the clear aqueous solution of potassium iodide and lead nitrate are mixed, double displacement reaction take place. So this is example, lead nitrate. Lead nitrate react to potassium iodide. See, lead nitrate, potassium iodide, both are colorless solutions. When these two are react, a yellow precipitate of lead iodide will be formed. Yellow precipitate of lead iodide, PbI2, that is lead iodide. The downward arrow mark indicate that product is a precipitate. Which will going to deposit at the bottom of the test tube. Then aqueous solution of potassium nitrate will be formed. Here lead nitrate. So the lead which is going to be displaced or replaced by potassium. See, lead displace potassium. Potassium displace less. So in the place of potassium, lead will be combined to give lead iodide. In the place of lead, potassium will occupy and going to give potassium nitrate. So this type of rearrangement of ions take place to give a product. Then you can also write one more example. You can write sodium sulfate plus barium chloride, sodium sulfate plus barium chloride gives barium sulfate plus sodium chloride. Sodium sulfate plus barium chloride gives barium sulfate plus sodium chloride. So in this, sodium sulfate is aqueous solution, barium chloride also aqueous solution, and the product barium sulfate is a substance, solid substance, which is in the form of precipitate, downward arrow marking output. Sodium chloride is a aqueous solution. So you write the equation in practice. Then next is the activity 10.2. Take a pinch of silver nitrate crystals. Collect about 5 ml of tap water in a test tube. Add silver nitrate crystal to water and shake well. Observe what happens in the test tube. Report your observation and what you infer from that. So silver nitrate, when react with the tap water, what happens? See, the tap water contains chlorinated. So because of this combination of chlorine, silver nitrate react with the chlorine, going to give silver chloride precipitate. White precipitate will be formed and nitric acid will be formed. You go to write equation silver nitrate, that is AgNO3, and with HCl gives silver chloride plus nitric acid. Then next one, see, neutralization reaction. This already you have learned in the 9th standard, 8th standard. That is the reaction taking place between an acid and a base. And see, it is another type of displacement reaction in which acid react with base to form salt and water. So normally when acid react with the base, salt and water are the common product. It is called neutralization reaction because acid and base both neutralize each other. Reactions of sodium hydroxide with HCl. This is a common typical neutralization reaction. Sodium hydroxide, that is a base, hydrochloric acid, that is an acid. When these two react, sodium chloride, common salt sodium chloride, and water are formed. This is a simple type of reaction which is going to be a neutralization reaction and displacement reaction. Similarly, one more example, that is ammonium hydroxide when react with the nitric acid. Ammonium hydroxide is a base, nitric acid is acid. So an acid react with the base, both are going to neutralize one another. Ammonium nitrate, water are formed. So ammonium displaces hydrogen from nitric acid. So in the place of NO3, ammonia will occupy the place of hydrogen. So ammonium nitrate and the hydrogen from nitric acid combine with the OH of ammonium hydroxide to form water. So next one, see, combustion reaction. A combustion reaction is one which the reactant rapidly combines with oxygen to form one or more oxides or energy. So combustion means nothing but this is a reaction of the process of burning. What will take place during the process of burning? That heat energy is liberated. Heat is given out. So combustion reaction, one of the reactant must be oxygen. So without oxygen, combustion will not take place. Oxygen is supporter of combustion. Oxygen is very essential element for combustion. So combustion reactions are majorly used as heat energy sources in many of our day-to-day activities. For example, in the domestic cooking purposes, LPG gases are used. So when LPG gases are burned in presence of oxygen, high amount of heat energy is produced because the constituent of LPG gas is propane, butane, propylene. These are the three important hydrocarbons present in the LPG, liquefied petroleum gas: propane, butane, propylene. So these hydrocarbons burn in presence of oxygen to give carbon dioxide, water, and enormous amount of heat will be obtained. See, propane formula C3H8. When this propane react with the oxygen burn in presence of oxygen, carbon dioxide will be formed, water, all these are in the form of gaseous state, and heat energy will be obtained. Then conceptual thought, all combustion reactions are oxidation, but all oxidation reaction not combustion. For example, you can see here one example also given, say that is uh, which of the following is the combustion, whether digestion of food or resting of iron. See, digestion of food is a slow combustion reaction. Resting of iron is, but actually both are uh, uh, oxidation. Both the reaction take place in presence of oxygen only. In presence of oxygen, digestion of food is a slow combustion reaction. Resting of oxygen is oxidation. So these two are oxidation, but we cannot say this combustion reaction is going to be a all combustion reactions are oxidation. Both the reaction, both the digestion of food, resting of ions are oxidation, but both things are not combustion. Resting of ion is not a combustion reaction. Resting of iron is not a combustion reaction, but it is an oxidation reaction. That's why it is given. See, there are so many reactions are there. The combustion reaction can be called as, because combustion that take place in presence of oxygen, that take place in presence of oxygen. So all combustions are oxidation, but all oxidations are not combustion. And heat is evolved, so it is exothermic reaction during the burning of uh, fuel. Enormous amount of heat is liberated, so it is an exothermic reaction. Exothermic reaction means a reaction which involves the liberation of heat energy. Liberation of heat energy. So combustion may be called as an exothermic reaction. A flame is formed, that is called burning. When the flame, so in the process of oxidation, resting of iron, no flame is called. And digestion of food also, we are not getting any flame, but we feel that hotness, the body temperature going to be maintained because of this digestion of food, because of this low combustion process. Then many thousands of reactions fall under the 5 categories, and further you will learn in detail about the reaction in your higher classes. So my dear students, you learn up to this the classification based on the direction of the reaction. We will see in the next class. So you have learned here in this session, that is single displacement reaction, that is a reaction between element compound. An element displaces an element from the compound. So a compound and elements are formed, and examples are given. And next, see the reactivity series given. Normally highly reactive element displays less reactive element from its compound solution. Then the difference between combination and decomposition reaction. Also in double displacement reaction, this is take place between two compounds react, the rearrangement of ions take place, interchanging of ions take place to give new product. So here cation can be replaced by cation, anion can be replaced by anion, and this type of reactions are called metathesis reaction. And two types, precipitation reaction and neutralization. Precipitation, and during the formation of product, any one product may be in the form of insoluble substance, that is called precipitate. And a neutralization reaction is a common reaction when an acid reacts with a base, salt and water are formed, that is called neutralization reaction. And another one, see combustion reaction. This is a reaction rapidly take place when the fuel burn in presence of combined to form enormous amount of heat energy. So for the burning of LPG, firewood, fuel, all these are combustion reaction, but all the combustion reactions can be called as oxidation, because these reactions take place only in presence of oxygen. Addition of oxygen is oxidation. But only when flame is formed, then only it is called combustion. But all the oxidation, addition of oxygen, flame will not be formed. So all the process will not be called as combustion reactions. Then classification we will see in the next class. So my dear students, go through and write and practice all the equations in your rough notebook. Practice, only regular practice will helps you, will enable you to understand, to know the reactant, molecular formula of the reactant and product, to write the equations. Then tomorrow you will have test. Tomorrow you will have test, already told, already I send a message, and you have to revise the lesson, periodic classification of elements. Periodic classification of element, you have to revise thoroughly. That is, a test will be conducted. Unit 8, periodic classification of elements, objective test, tomorrow morning, Sunday, morning 8 a.m. to 9 a.m. So you have to get ready with your device. First you prepare well, prepare your device, and the link will be given 8 a.m. to 9 a.m. only. Half an hour enough to complete a test. Only objective test you can finish even within 5 or 10 minutes. 10 minutes enough. So don't give reason. Then thereafter question will not be available in your device. So only 8 a.m. to 9 a.m. question will be given. Link will be given. Use it. Choose the correct answer and do well. Wish you all the best. Thank you. God bless you.